So this is our M&M project, as you can tell by the M&Ms, and we primarily measured 3 variables, one categorical, which was the color of the M&Ms, and 2 quantitative, which was the length in centimeters and the weight, which we measured with a scale in grams. We used a ruler for the other quantitative variable. The thing I'm going to explain is 5-number summary and analyzing measure. 5-number summary is basically your minimum, maximum, median, and your two quartiles, quartile 1 and quartile 3, and then you can analyze a distribution using SOX, which is shape, outlier, center, and spread. Shape, you can look at symmetry, skew, and modes, which is basically it's the same on either side of the median. That's not symmetrical, that's skewed. And then your mode is just how many peaks you have. You can have a unimodal, bimodal, trimodal, etc. Outliers you can see by saying, is it quartile 1 minus 1.5 times the IQR times 1.5 times the IQR minus, and the quartile 1 minus that. Or you can do quartile 3 plus 1.5 times the IQR. If it's greater than this, it's an outlier, and if it's less than this, it's an outlier as well. Center, you can look at mean or median. Mean is non-resistant, so it's better to look at median when you have a non-symmetrical distribution or if it has outliers. If you're looking at your median, you should look at IQR for your spread, and if you're looking at if it's a symmetrical, non-outliers distribution, you should look at range. With your mean, you can also use standard deviation, which is basically the square root of variance, which is your x value, the sum of your x values minus your mean all over n.
So I wanted to represent the relationship between my explanatory variable, which is the length, and my response variable, which is the weight of the M&Ms. And I did this using a scatter plot. And it's going to look something like this, with the explanatory variable on the x-axis and the response on the y-axis. Nice. Since I am looking at the relationship between these two variables, and they're both quantitative, it's kind of inevitable that I'm going to be looking at the correlation, which measures the direction and strength of the linear relationship between two quantitative variables. There is a equation for this, but it's like the worst. Correlation equals 1 over n minus 1, and then the summation of x minus the mean of x over the standard deviation of x times y minus the mean of y over the standard deviation of y. Well, it is important to kind of conceptually understand what equations are trying to tell you. A lot of times it's just a lot faster and more efficient to do things on your calculator. So you can calculate your correlation on your calculator using LinReg, and for the M&M data that we got, the correlation is R equals 0.63303, which means a couple things. So, correlation is always going to be between -1 and 1. The closer it is to 1, that means the stronger the correlation is. Since here we have a positive correlation, that means there's a positive association between the two variables. In addition, correlation is not resistant. So you want to make sure you're finding the mean and the standard deviation of both of the variables as well.
Okay, so in order to create probabilities, we need to have empirical data to go off of. And we had empirical data because it was our observations of the M&Ms. First, we can start with chapter 2, where we have the z-score, which all of you are familiar with, I hope, which is the x value minus the mean over standard deviation, and then you can use your calculator to find that, which will tell you how many standard deviations away from the mean the number is, and then you can use that number to find the percentile using table A or your calculator. Then we use that to create density curve graph. So here we have a two-way table where we measured the texture of the M&Ms, smooth, moderately bumpy, or extremely bumpy. Then we have our colors yellow, brown, orange, green, red, and blue. And our totals, where here we can find any given probability for, let's say, finding green would be 9 over 38. An example is probability of finding green, or our probability of choosing an M&M that is either green or smooth. So we have the probability of choosing a green one, which is 9 over 38. Plus the probability of choosing a smooth one, which is 10 over 38, which you can find these values here, minus the probability of one that is both green and smooth, which is right here. So that's minus 3 over 38. And then we'll find that that's 16 over 38, which is about 0.4211.